Here's problem 3724. Non-reflective coatings for camera lenses reduce the loss of light at various surfaces of multi-lens systems, as well as preventing internal reflections that might mar the image. Find the minimum thickness of a layer of magnesium fluoride, n equal to 1.38, on flint glass, index of 1.66, that will cause destructive interference of reflected light of wavelength lambda equal to 550 nanometers, which is near the middle of the visual spectrum. Okay, so keywords here are finding the minimum thickness causing destructive interference. And our situation here is that we have light coming from air going through magnesium fluoride, which has an index of 1.38, and then going into flint glass, which has an index of 1.66. So the light would come in, refract toward the normal, and reflect. Upon this first interface, the reflection is going to have a phase reversal because we're going from a lower index to a higher index. So there will be one phase reversal there. And upon the second interface between the magnesium fluoride and the flint glass, there will be another phase reversal because we're going from a lower index to a higher index there as well. So we're going to have two phase reversals due to the reflections off these interfaces. And left to those devices, that would keep us in phase. That would put us one total cycle out of phase and put us right back into phase. So left to that, we would be in phase and we would have constructive interference. So we want the path difference caused by the thickness of the magnesium fluoride to give us another half cycle so we can have destructive interference. So we want 2t to be equal to m plus 1/2 times the wavelength within the magnesium fluoride. So this wavelength within the magnesium fluoride is the wavelength in air divided by the index of refraction of the magnesium fluoride. So we're going to have 2nt is m plus 1/2 times the wavelength of the light. And we want to find the minimum thickness. So t is going to equal m plus 1/2 times the wavelength over 2 times n. Since we want the minimum thickness, we're going to choose m to be 0. And this will give us 1/2 times 550 nanometers over 2 times the index of refraction of the magnesium fluoride, 1.38. And what is all that? .6 nanometers. So that is the minimum thickness of the magnesium fluoride coating on the flint glass that will reduce the reflections and give us destructive interference, 99.6 nanometers.